All right, now we're on to our last section of the chapter, section 6.6. All right, and in here we're going to talk about some more special quadrilaterals, this meaning four-sided figure. All right, so it's not a parallelogram, it's just a quadrilateral. All right, and you'll see one of the ones that we're going to talk about today is an isosceles trapezoid. And you'll see it's very, very similar to a trapezoid that we learned already. To an isosceles triangle that we've learned already. So in an isosceles triangle, we have two congruent sides, and each of these congruent sides were called our legs. The sides that were not congruent, side that was not congruent was called our base. And then our base angles, or the angles opposite of our legs, were congruent. So you'll see today the isosceles trapezoid is very similar to our isosceles triangle. And another thing that we learned about the isosceles triangle is its midsegment is equal to 1/2. So if this is A, this is B, C, D, E. So DE is equal to 1/2 of AB. And you'll see all of this is very similar to what we're going to do now. All right, so a trapezoid. First, before we get into isosceles, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Right? So in this case, it's a four-sided figure, and all we know is that it's exactly one pair of parallel sides. All right? It's exactly one. The parallel sides of a trapezoid are called the bases. Right? So these two sides that are parallel are called the bases. And then the other sides are your legs. Right? The two angles that share a base are called the base angles. Right, just like they were before. So a trapezoid has two pairs of base angles. Now, this is not an isosceles trapezoid, it's just a regular trapezoid. But the consecutive base angles, so meaning if this is angle A and this is angle B, right? So the consecutive angles that are not part of the same base, they will be supplementary. So this angle A plus the measure of angle B is equal to 180 degrees. And if this is C and this is D, that means these two angles, so these aren't saying that they're congruent, I was just referring to A and B. And since these are consecutive angles that are not a part of the same base, the measure of angle C plus the measure of angle D is also equal to 180 degrees, because here we have two parallel sides and here we have our transversal. All right, so if we have a trapezoid, we know that these two angles are same side interior angles, and these two angles are same side interior angles, so they have to be supplementary. All right, so that's a trait about a regular trapezoid that we have. All right, now, what happens when the legs are congruent? Well, just like in the triangle that we were talking about in the beginning, when our legs were congruent, it was an isosceles triangle. Well, here, when our legs are congruent, it is an isosceles trapezoid. And it's very similar to what we just did in this triangle here. Our base angles are going to be congruent, but in this case now we have multiple base angles, so we have to be a little wary about that. And you'll see our midsegment is almost identical to what we have here. All right, so some of the traits, you're just going to have to be able to write these down. Whatever you guys need to do, like I said in the other videos, you guys just have to memorize these. All right, if it's an isosceles trapezoid, then each pair of base angles, mean each pair, so they have to be the same base angle, so they have to be touching the same base. They are congruent. So A is congruent to D, and B is congruent to C. All right, it's not that C and D are congruent because they're not part of the same base. They're not the same base angles. All right, so it's the same base angles are congruent, just like in an isosceles triangle. The same base angles are congruent. All right, just like in a regular trapezoid, these angles are also going to be supplementary. All right, so don't forget about that. All right, and a way that we can tell if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So even if they don't give us that the two legs are congruent, if they give us this information here, then we're able to conclude that it's in fact an isosceles trapezoid. So in blue, I'm going to put what we can jump to. So we can say that these are congruent, and then we can say that these angles are congruent as well. All right, and if it's an isosceles trapezoid, then its diagonals are congruent. All right, so if it's an isosceles trapezoid, then its diagonals are congruent. All right, so it's another trait that we have about the isosceles trapezoid, that the diagonals are congruent. And the last thing that you'll have to know is the midsegment. All right, so it's very similar to the midsegment of a triangle, in that it is a segment that connects the midpoint of both sides of our triangle. Well, here, it's a segment that connects the midpoints of both sides of our trapezoid. And the midsegment is equal to 1/2 of the sum of the two bases. So it's almost identical to what we have here. It's 1/2 of the base. Well, in a trapezoid, we have multiple bases, so we need to add them together. All right, so it's 1/2 the sum of the two bases. All right, so now let's go ahead and do a problem. So we want to solve for the measure of angle D, the measure of angle E, and the measure of angle F. All right, so since it is an isosceles trapezoid, I know that the base angles are congruent. So the pair of base angles are congruent. So I know that angle C is congruent to angle F. So really quick, before anything, the measurement of angle F is equal to 65 degrees. All right, now I've said this a few times already. These two angles we know have to be supplementary because here is our parallel line. Here is our transversal. So these two angles are same side interior, so they're supplementary. So then the measure of angle D plus 65 is equal to 180 degrees. We subtract over 65, and that means that the measure of angle D is equal to 115 degrees. So the measure of angle D is 115 degrees. Now, I don't have to do anything else because I know it's isosceles, so I know that D and E are congruent. So the measure of angle E is also equal to 115 degrees. All right, pretty quick, pretty simple, pretty easy, I think. All right, now the last one for here is finding the midsegment. All right, so we want to find, so this says what is X? So it tells us it's the midsegment. So we know that it's the midsegment. It tells us it. And then if it didn't tell us it, another way we can know is if they gave us this tick marks. So I know that the segment QR is equal to 1/2 of the sum of the bases. So it's 1/2 of LM plus PN. So that means that X plus 2 is equal to 1/2 of 4X minus 10, which is LM, plus 8. So we'll combine like terms here. So X plus 2 is equal to 1/2 of 4X minus 2. Now I'll distribute the 1/2 in. Or you could have multiplied by its reciprocal, it doesn't matter. But then X plus 2 is equal to 2X minus 1. Finish this up here. So X plus 2 is equal to 2X minus 1. So we'll subtract over the X and add over the 1. So that means that X is equal to 3. And that's all it asked for. It didn't ask for anything else. So we can stop there. All right, that's the end of this video. And in one more video, we're done section 6, and we're done the chapter then, because that's all we're doing in this chapter. And then there's another review video at the end of that.